Okay, now we're on number 9 of this set of problems, and it's an iron cooling problem. The face of a household iron cools according to F of t equals 20 times 2 to the negative 1.9 t plus 75, where t is the time in hours since the iron was turned off. Okay, so I've started you off by sketching in a few things for the graph, and then I want you to think about the domain and try to set this up, and then you can also graph it in Desmos, but remember, just use x in place of t so it works out for you to recognize that variable. So I picked 75 for the horizontal asymptote because that's how it would shift up. We have a reflex, so it's going to go the other direction. So our little sketch, see if you can figure out how that would sketch in and then check it in Desmos. Also think about what your domain should be for t. That's going to be in hours. And then your f of t is temperature after that number of hours. I actually want to show you how I type this in Desmos, just in case you're having any trouble with that. You can see how it works. So I would start in my box and then do 20 times, I'm going to use parentheses just to make sure that works okay, 2 to the power, I'm raising it up, so I'm going to do this a to the b, negative 1.9, and I'm going to use x for my input. And then if I just hit the parenthesis there, it stays up in the exponent, so I don't want to do that. So I want to arrow over and then put my parentheses, and then it comes out in the right spot, and then I'm going to add the 75. And now it looks like, oh, there's no graph there, but if I look at my scale, I need to just change that down so it shows. Okay, and for the first part of the problem after the graph, the first calculation you're going to make is f of 0, and you can look right here. You can use your Desmos graph and see that 0.95 is when no time has passed. So that's actually where we're going to start. We don't want to start over here when our time is negative, so that wouldn't be part of our domain. So kind of think about like the domain restrictions at that point. And you can also see where that horizontal asymptote is at 75, right in there, that it's approaching, and it's kind of like this really pretty steep curve there, or descent, you know. So let's go back to the other page, and we can fill in some of our stuff here. So f of 0, I would put 0 in for the values. So I would have 20 times 2 to the negative 1.9 times 0. I mean, you can just do that in your head. That would be 1. You wouldn't necessarily have to write that out. And so we would get 95 degrees when no time has passed. Okay, so say something to that effect, that the initial temp of the iron is 95 degrees. It was. Okay, and that is in, I'm assuming, Fahrenheit. For part C, find the horizontal asymptote of this function and explain its meaning in everyday language, which we did for the graphing, so we have that there. So the horizontal asymptote is y equals 75 degrees, and it means that the temp won't go below 75 degrees. It'll approach it. I mean, it would basically be at room temperature after a while. So we do want to think about what our domain is again, like how that would work. And so we can go back up here and think about that. So at 0, so our domain could be 0. We could include 0 because we have that initial. And then maybe it's hours, 5 hours. That's what I have. But you could really have anything. You could have like how long are you going to leave the iron sitting there cooling? You know, maybe even just a couple hours or something like that. We'll say 2. But that could vary, whatever you want to put in there. D, estimate when f of t equals 80 and explain the meaning of your solution in everyday language. So we can look at the Desmos graph to help with that. You could pop some numbers in there to kind of judge. Like if you figured out one way to do this is just like kind of figure out like do f of 0.5, pop that in. Just do it on your calculator and figure out what you get. Maybe try f of 1 and f of 2 and see what you get. So go ahead and crunch those numbers in your calculator and then check back. You can also then look at the Desmos graph and see, you know, when that's going to equal 80 and try to see if you can blow it up a little to see that. And I'll show you that momentarily. So jot this down. Okay, so I just popped in numbers till, you know, I have something a little bit around 80. So it's, I would say it'll take a little over an hour for the iron to cool to 80 degrees. We can also look at our Desmos graph and check it out here and put our point around 80. I can't get it exactly, but a little tiny bit over an hour. Thanks for watching. I hope you found that helpful.